Okay, so for section 7.5, Algebra 1, we're going to talk about solving special types of linear system, and then there's 4 boxes. We're going to begin by reviewing what a system is of linear equations. So if I have x minus y equals 3, and I have 2x plus 3y equals 16, I'm going to go ahead and solve those by graphing. So I'm going to put both of those onto the coordinate plane, and I can see that from the graph, the point at which they intersect is the solution to the system, and that point looks like it is 5, 2. So x is 5 and y is 2. So my solution would be, for this one, it would be 5, 2. My x, and that's my y. And that's what we've been doing so far. And remember, there's 3 ways that we can solve a system of equations. We can either solve by graphing, which we did here, solve by substitution, or by elimination. Well, what happens when the graphs don't turn out to be exactly the same? So take this one for example. I have negative 2. Go ahead. The same and take their solutions here. Okay. So from what we know, I'm looking for the point where these two graphs cross, right? Well, these graphs are parallel. They're exactly parallel. So it doesn't matter in zoom or no matter where I'm doing, these two lines are never going to. So how can a solution have a system? How can a system of equations have a solution if the lines never cross anywhere? So that's the whole point of this idea here. So that's what we call an inconsistent system. It's a system in which the lines will never cross. There's no single point at which they will ever cross and have a single solution, as in relation to the last one where the point was 5, 2. Well, that's just not going to happen on this parallel line. Therefore is slope of my two equations is equal. That implies that we're going to have an So that's what an inconsistent system is. And the reason it works is because the lines are parallel and they have no points in common. That's what we call an inconsistent system. And there's another special system that we have to consider, and that's what's known as a consistent dependent system. So I'm going to and get line here each other. See down here? These two equations are just copycats of one another. This one is 3 times this one. So what that means is that I have got 2 lines that are right on top of each other. So the question then is, well, how many solutions are there? Well, there's an infinite amount of solutions for this one. Infinite amount of solutions. And that's because no matter where you point to, let's say I point to this point right here, right? Then that is a solution, but so is this over here, and so is that down there, and so is this right here, and there's an infinite amount of these points because these represent the same line. So when a system represents the same line, we have an infinite amount of solutions, and we call that a consistent dependent system. All right, and lastly, let's try this one here. Let's describe the system. I have 2 of these. I have A and B. All right, well, this one is algebraically thing. Y equals, and this one says choose substitution and plug the y in for this value here. So I'll have something that's like this. I'll have 4x minus 2 times, I'll replace y with 2x minus 7, that's my substitution, equals 14. I'm going to go ahead and use the distributive property here and get 4x minus 4x plus 14 equals 14. Well, you can see that the 4x and the minus 4x goes away. So that gives me 14 is equal to 14. That's what we call a true statement. So if that's a true statement, which one do you think it has to be? Do you think it has to be a consistent or an inconsistent system? And you probably guessed right if you say system right there. Or substitution. So this helps. Four x plus 4x, that goes away. So I end up with 2 is equal to 4. And that's a false statement. We all know that inconsistent system. So those are two ways to check to see whether or not your system is inconsistent or consistent without having to graph it. So in review, we have a normal system of equations. Wherever they cross, that's going to be our solution. But sometimes, and in fact, means there's no solution, and we call it a consistent system. And sometimes the graphs are copycats of each other and they're right on top of each